Well, we've got a big day today. We're going to look at radical equations. So when we talk about equations, what we mean is that all of a sudden there's going to be an x or some other variable in our radicals that we need to solve for. And I know how much you guys love to solve for x. It is truly one of my favorite things. We are going to look at this in two different types. The first type is going to be when we have one variable, and then the second type is going to be when we have two variables. Creative, huh? So this is going to be like every algebra problem we've ever solved. We're going to have to pay attention to order of operations. We're going to have to isolate our variable. We're going to do all the stuff we know how to do, all with a radical. Now, the key to this is that radicals are like, squiggly equal means almost similar to, are like brackets. So when numbers are in a radical, it's like being in a bracket. You have to keep them in there. They function as a unit. You have to, they function as a group. So for order of operation purposes, everything in the radical stays in the radical. Okay, let's look at one. So here's our first example. What if we have 5 plus the square root of 2x minus 1 equals 12? Now, we can look at this, logically with some mental math, and we can ask ourselves, 5 plus what equals 12? Well, 7, right? 5 plus 7 equals 12. And then we can say, okay, well, we're at some point going to have to take the square root of something. So what number has the square root of 7? Well, 49. Okay, well, what number do we subtract 1 from to get 49? 50. Well, what do we double to get to 50? 25. So I can logically work my way through this if I really wanted to and come up with that number, but we need a procedure. And just like everything else, we are going to do this in pieces. Now, what I said a second ago is that everything in the radical is like a bracket. So our goal in algebra is always to get the x alone. Well, in this case, when the x is inside the radical, the first step we're going to do is isolate the radical. Okay, we're going to isolate the radical. So that means I need this 5 to move. It's a positive 5, so to move it, I'm going to subtract it. That's the 7. I'm going to subtract it from both sides. That's going to leave me the square root of 2x minus 1 equals 7. Sorry, 12 minus 5 is 7. Okay, now we need to remove this radical. So just like the opposite of adding is subtracting, the opposite of a square root is to square. So to get rid of our radical, so we're going to remove the radical by squaring everything, right? Because what you do to one side, you have to do to the other. Remember, up here, we subtracted 5 from the left side of the equal sign and the right side. So if I'm going to square both, I'm going to square this, then I need to also square my 7. Whatever I do to the left, I have to do to the right. If I square radical, all that's left is the inside, is my 2x minus 1. That's like saying, if you take the square root of 3 times the square root of 3, let me write that down. The answer is the square root of 9, which is 3. The square root of 7 times the square root of 7 is the square root of 49, which is 7. So do you see the pattern? When you square a radical, all that's left is a radicand. So if I apply that here, then the square must be 2x minus 1. When I square 7, I get 49. Now I just have a nice, easy algebra problem. I'm going to move my 1, and I'm going to get 2x. I'm adding that 1, because it was subtracting, is 50. Now I have 2 times x equals 50. Divide out my 2, and x equals 25. And that's it. Now I'm going to go back and make sure that this really does work. So with radicals especially, it's really important that we check our work. And to do that, all I'm going to do is rewrite my problem and plug in the number that I think is x. So I'm going to plug in 25 here. Keep that all under the radical. And now I'm just going to work this out. So 5 plus 2 times 25 is 50, minus 1 is 49. So the square root of 49 equals 12. I'm not rearranging or moving anything when I check. I'm just working it out, keeping everything where it belongs. Okay, the square root of 49 is 7. So 5 plus 7 is 12. 5 plus 7 is, in fact, 12. So this checks. It works. Really important step in radicals. Something we don't usually take the time to do, but in radicals, it's going to make a big difference. Okay, so that's what it looks like with one variable. Let me go through that one more time. The first thing you do is isolate the radical. You have to get the radical alone on one side of the equal sign. Once that's happened, you square everything, both sides, put it in brackets, square it all, and then you just solve. Solve for x with your normal algebra processes. Finally, run it right through one more time and check it, make sure your number works. Okay, let's see what happens when we have 2 radicals. Now, fair warning, this is going to get a little rowdy. I didn't mean 2 radicals, I meant 2 variables. Okay, so when we have 2 variables, it looks a little bit different. So let's start with this example. We're going to say x minus the square root of 5 minus x equals -7. Now, I know it's ugly. There's lots of x's or lots of negatives. But what did we say was our first step? Our first step is to isolate the radical. That means I need this radical to be by itself, which means that x needs to move and the negative needs to go. So I'm going to say the square root of 5 minus x equals -7 minus x. Oops, I still have a negative here. Now, remember, this is like a -1. So if I divide everything in my next move by -1, then I'm going to have the square root of 5 minus x equals 7 plus x, which is far nicer. So I've isolated my radical. Do you see how my radical is all by itself? There's nothing else over here on the left side of the equal sign. Now, the second move is to square everything. And when I say that, I mean it. So put brackets around this, square it. Put brackets around this, square it. Now, in that last example, we said that when you square a radical, all that will be left is the radicand. So 5 minus x. Not the case over here. This, I'm going to draw this off to the side. This is like 7 plus, 7 plus x squared means I have 7 plus x why can I not write this? 7 plus x twice. And if I multiply this out, I get 7 times 7 is 49. 7 times x is 7x. X times 7 is 7x. X times x is x squared. You're right, it was 2 brackets. It's a trinomial. So this is going to give me x squared plus 14x plus 49. So there's that. So x squared plus 14x plus 49. That equals 5 minus x. Now, what do we know about solving algebra problems? We need to get the x alone. So the issue here is that if we rearrange this, we're never going to get x alone. So instead, we're going to put everything on one side. So we're going to move this 5 over. We're going to move this 5 over, and we're going to move this x over. And that's going to leave us 0 equals x squared. 14x plus x is 15x. 49 minus 5 is 44. I lost my x. Thanks for reminding me. So the reason we did this is because whenever you're trying to solve for x and you've got a quadratic function, your best bet is to create a quadratic function that equals 0, because when it equals 0, we know that we can factor it and solve for x, just like we have always done in our quadratic units. So if we do that, we ask ourselves, what two numbers multiply to x, or to 44, and add to 15? Well, 4 and 11, right? So now think back to quadratics. If we separate these, we have x plus 4 equals 0, and x plus 11 equals 0. Well, what gives me a 4, or what gives me a 0 here? What plus 4 is 0? X equals negative 4. Okay? And here, it must be negative 11. Hold, please. Okay, so, sorry about that. This looks all good, but remember what I said, that our last move on these is to double check our answers. So right now we have 2 answers, negative 4 and negative 11. We are going to plug these bad boys in just to make sure that this works. So I'm going to take that negative 4. I'm going to go back to my original equation, which, just for the record, was x minus the square root of 5 minus x equals negative 7. I'm going to plug that negative 4 in. So negative 4 minus the square root of 5 minus negative 4 equals negative 7. So remember, do not rearrange. Don't move anything. Just make it all equal each other. What is 5 minus negative 4? Well, that's the same as plus 4. So this is the square root of 9 equals negative 7. So negative 4 minus 3 equals negative 7. Negative 7 equals negative 7. Perfect. Good. Negative 4 is, in fact, an answer. Let's do that again with our negative 11. So I'm going to plug negative 11 in this time. Negative 11 minus 5 minus a negative 11 equals negative 7. Negative 11 minus 5 plus 11 is 16. So the square root of 16 equals negative 7. So is negative 11 minus 4 negative 7? No, it's negative 16. So does negative 16 equal negative 7? Nope. Therefore, over here, come back over here, negative 11 is not an answer. And I know what you're thinking. Someone is very clever and they're saying, well, good boo, isn't the square root of 16 plus or minus 4, which would make this a negative 4, and then you'd have negative 11 plus 4. You're not wrong, except we only use primary square roots here, which means the positive. So therefore, while that's part of why this problem is misleading, is because it does produce that potential negative 4, but that's not the primary square root. So therefore, this answer, this negative 11, was a fake answer. And it has a name. This is called an extraneous root. So it's a fake answer. The word root, remember root is another word for 0 or x-intercept. So root just means a number that will produce a 0, right? Like that 0 we were looking at. So extraneous means it's extra, it's outside, it doesn't work. So the actual answer to this problem is negative 4. This is why checking our work in radicals is really important. And I know we're not used to checking it, but it makes a big difference, especially when we're dealing with two variables. So make sure you work through it. So as a quick recap, you are isolating your radical, squaring both sides. If you get a quadratic, put everything on one side, so you have 0 on the other. Factor, so solve for x. To do that, you factor, get your two answers, check them both. When you check, you're only looking to see what the number condenses to. You are not rearranging. If your answers don't match, you have an extraneous root. It is possible to have two answers. You will not always find an extraneous root. Okay, Merry Christmas. There you go. Done. Happy New Year.